Hello, my name is Daniel Jilic, and this is my presentation for the Midterm Teaching Review. So, a brief look at the agenda of what this presentation will contain. I'll first show a concept map, which will be a simple visual representation of all the topics that we've covered so far in the semester. I'll then go into an overview of all of these topics, briefly explaining them and what we've learned. And this will continue up until the last topic which we covered, which was MongoDB and databases. I'll go more in depth on this and fully explain what we've learned. And then finally, I'll do a brief live coding session. So here's the concept map that I developed for what we've covered in the semester so far. I think the best way to really break down what we've learned has been to treat concepts or technologies and then also the architecture of what a website contains separately. I thought this was the best way to break it down, although there's definitely overlap. Of course, the languages shown in concepts are used to build the architecture. But this is essentially everything that we've learned so far in the semester can be broken down into one of these categories. So this is just a very broad picture of everything that we've learned. So in the concepts or technologies, we started with HTML, hypertext markup language, and this is technically the only thing you need to build a website. This is basically the structure and the actual content of the web page. And here we also looked into, the specifics of how to actually code up a .html page and run it in a browser. The next concept is CSS, cascading style sheets. This is the styling of a website. So if HTML gives you the structure and content, that doesn't really look very impressive. It's technically a web page and it functions. You could read information off it. But CSS is really what gives it that pleasing appearance, a web page that someone wants to come back to. So these style sheets are applied to the HTML document to create finally what it's actually rendered on the screen. And in class, we covered a CSS framework called Bootstrap, which is essentially just to speed up the process with predefined classes and styles that you can use. And you can actually put directly into the HTML to really streamline the process of styling the web page. The final language that's used to create a web page is JavaScript. And this is, as the name implies, the scripting language that allows you to add functionality to the web page. Two of the concepts that we went over in class and really kind of went a little more in detail into were closures and modules. And so I'll go into detail and describe these later on in the overview, but they're aspects of the JavaScript language that can be a little different from others and are important to understand. The other main category in the concept map is the architecture of a web page. And so this is how is an actual full stack web application built? How does what we program actually get to the end user? And so within the architecture, you can break it down into really three sections: the front end, the back end, and the database. For the front end so far, we've only covered static pages, which are pages that are delivered to the end user by the server. For the back end, we looked at Node.js and Express. So the back end is just the server in the client server model that the internet uses. And so since any JavaScript code that we write for the server isn't actually being run in a browser, we need a runtime environment to run it. And so Node.js is that runtime environment that allows us to code up the server in JavaScript. And Express is just a framework to allow us to do this. It streamlines the process of making that server in Node.js. Finally, the last component in the architecture of a full stack web application is the database. This is obviously where you store data long term, and we looked at MongoDB, which is a NoSQL database that's very popular in the industry. So now that we've seen how all the concepts that we've covered so far this semester fit together, I'm going to go over an overview of all of these concepts and explain briefly what we've learned about them. The first concept that we covered was HTML, which stands for Hypertext Markup Language. And a markup language is just something that encodes how text should be structured on a page. And that's exactly what HTML does for the internet. Having a standard markup language like HTML allows any client, no matter who they are, to parse the same document, the content and structure from a server and display it in the same way. So HTML is just the machine readable syntax for that content and structure. And it's pretty simple. The picture on the right shows an example from some HTML that I wrote. You can see that it's broken down into elements, and elements are the things that you see between the open and closed brackets. So, for example, on line 20, you can see the beginning of where it says UL in brackets, and that stands for an unordered list. And down here on line 33, we see the closing brackets of that unordered list. So that's everything that's enclosed within that is one element, the unordered list. And the UL itself within those little brackets is called the tag. And the tag is just the name of the element. So browsers will load this HTML document and they'll convert it into what's called a DOM tree, which stands for Document Object Model. And the DOM is just taking those elements in the HTML and putting them and making them into nodes in a tree data structure. So the picture on the right shows part of the body of an HTML document. And the head and body are two elements in an HTML document uh, that they all have. Each HTML document can be broken down into a head and a body. And the body is mostly used for the actual content and structure. And the head element is going to be used for metadata about the web page itself. The next concept is CSS, which stands for Cascading Style Sheets. And this is the language that's used to actually style the web page that you've created in that HTML document. So, as the name kind of implies, it's a style sheet language, not really a programming language per se. CSS is made up of selectors as well as the style properties for that selection. And you can see that in the image on the right, which is an example of CSS code. So in that sort of yellow orange, like on lines 8 or 12, those are selectors, and that allows you to select certain elements within your HTML document by either their type, which is the element itself, such as HR down here, or a class using a dot. So here, this will be a navlink class, or the ID using a hashtag symbol, like on line 8, hashtag carousel. And within the brackets for each selector is where you'll define the actual style properties, which are very numerous. You can have color, margin, border, various text properties like color, alignment, and font, and many other things. And you can even be more specific about which elements in the document that you want to apply those style properties to. So, for example, in line 8, you can see that there's a space, there's a hashtag carousel and an image. And what this means is that whatever style properties are within the brackets, are going to be applied to any elements that have a type of image that are a descendant of an element with the ID carousel. So CSS uses what's called a box model, where every element makes up a rectangle. And if you want to get it more advanced in laying out those rectangles, you can use some of the layouts that CSS provides, like grid or flexbox. And you can also apply transitions and animations to elements. CSS isn't just a style sheet, but it's a cascading style sheet, meaning that the rules cascade downward. And that can lead to conflicts. And when rules conflict, that's where specificity comes in, which means that CSS will apply the rule that has a more specific selector. So, for example, a rule with a selector of two classes will apply over one that just has one class in the case that they conflict. We also covered Bootstrap, which is a CSS framework that just streamlines the process of styling a web page by providing a developer with predefined styles. And these styles can be added directly into the HTML as classes. One of the primary focuses of Bootstrap is its layout components, especially containers, and it has its own custom grid system that's actually built on Flexbox. And these containers can be assigned breakpoints to allow for responsive design, such as depending on the size of the window. And if we go back a couple slides here in HTML, you can actually see one of those Bootstrap containers being applied as a class directly into HTML here on line 19. The programming language used in web development is JavaScript. JavaScript is a dynamically typed language like Python, but it has a C or Java family style syntax. And it supports both object-oriented programming with the use of prototypes, as well as functional programming. Each object in JavaScript inherits properties from its prototype, and this can go on a chain called the prototype chain all the way up to the null object, which itself has no prototypes. JavaScript has three variable declaration keywords. Constant, const declares a constant, which is a value that can't be changed. Let declares a block scope variable, pretty standard, and var is mostly deprecated. JavaScript is single-threaded, but it does have an event loop, which allows for asynchronous programming, which is particularly important when we're talking about a language used on the internet, and there's network connections that could take a while, or they could be extremely fast. One of the important features of JavaScript is the closure. And closures are a combination of lexical environment, that is the current state, and the function itself. And they're unique to JavaScript, and they allow you to do some interesting things. In the picture on the right, you can see that the function makefunc is defined and assigns a variable name with the value of Mozilla. And then within that function, another function is defined. And the original function will then return that nested function. And down here, myfunc is called. And while this wouldn't work in other programming languages, in JavaScript, this will actually successfully log the variable name to the console. And that's because of the closure. So when we define this function display name, the lexical environment of that function, which includes this assignment of the string Mozilla to the variable name, is included in that closure. So then down when we call it here, we still have access to that variable. And finally, we covered the use of modules, which allow you to split up your JavaScript programming into multiple files and export functions from one file and then import them in another. And this allows you to do modular programming in JavaScript rather than having to link a bunch of scripts to your HTML document. Moving on to the backend component of the architecture, we learned about Node.js and Express in order to create a server for a web application. Because a server isn't being run in a browser, and that's normally how JavaScript is run, we need some way to run it outside of a browser. And Node.js provides that. It provides us with a runtime environment using the V8 JavaScript engine, and its main purpose is exactly to create web servers in JavaScript. Express is the framework that we use in Node.js to actually create that server. And within Express, we can add routing for HTTP requests and create a REST API. HTTP requests are the way that clients and servers communicate, and the client can get information from the server, such as the HTML document, the CSS, any JavaScript, etc. And the way it does this is by making what are called requests. These requests are sent by a specific route to the server, and they're going to be different request headers depending on what you actually want to do with that route. For example, the get header tells the server that I want to get some information from this route. On the other hand, the post header tells the server I want to store some sort of information at this route. And so typically the backend will respond to these, and we code this in Express, where it handles the routing. And depending on the route, it might then perform some operation. For example, if it receives a post, it might verify that it's a legitimate request and then put the information that's encoded in the request into the database. We generally want to code this Express backend or any other kind of server framework as a REST API. And REST stands for Representational State Transfer. So what this means is that there's essentially a total decoupling between the server and the client. And each request that the client makes to the server is totally independent of any other request, either by a different client or that client itself. So this allows for, because there's no state saved between the requests, um, it's a total independence of the client and server. The last topic that we covered this semester so far is databases, and specifically we looked at MongoDB. So now I'm going to go a little more in depth in this topic and explain MongoDB, how it's used, and why it's useful. MongoDB is a NoSQL database management system, and NoSQL database management systems are those that are not relational database systems like SQL. And so, unlike SQL, they're extremely flexible in how they store data. You don't need a schema. And instead of essentially a table organization, the organization of the data is document oriented for MongoDB. And these documents consist of a series of key value pairs where the key is a label and the value is the actual data that's being stored. MongoDB uses what's called BSON, which really stands for binary JSON. So this is basically the actual document itself is made in a JSON-like structure, but it's using a binary encoding that allows it to be the performance is greatly improved compared to JSON. And in addition, it has some additional data types that are not present in regular JSON. So now let's look at what an actual MongoDB document looks like. So MongoDB stores data as documents, which are essentially the equivalent of a row in a relational database. And these documents are stored in collections, which are the equivalent, more or less, of a table. As you can see, although this document is not actually JSON, like I mentioned earlier, it's BSON, the structure is functionally identical. The entire document is enclosed in braces here, and key value pairs are separated by colons. The pairs themselves are separated by commas, and we can even have documents embedded within documents, as shown here, where the active games key corresponds to a list of values, and each of those values can be its own document. And this is just one of the ways in which MongoDB is extremely flexible. Here, this relation uh, between entities can be represented like this rather than having a separate relational table as in a something like SQL. Now that I've gone over the basics of MongoDB and what it is, let's look at some of the features that it offers. MongoDB has sharding. Shards refer to the broken up pieces of data that are stored on different servers. So a lot of databases use this in order to allow individual servers to not get bloated, because if a single database server has to store a ton of information, databases can get extremely large. Then if only one of them is doing this, it's also having to handle all the requests to that database. So when it has all this huge amount of stored data, as well as a ton of possibly not separated by a large amount of time chronologically, those requests, this can cause these requests to get bogged down and very slow. So sharding allows these, not only the data to be broken up, but also the requests can get routed to the different database servers that are holding that shard. So additionally, MongoDB has replication, which refers to not only is the data broken up as shards and stored on different servers, but there's actually multiple copies of the same chunks of data stored on different servers. So that means, of course, if a database server goes down, maybe it's intentional for maintenance, maybe it's not intentional, maybe it's temporary, just it crashed and can be rebooted, or perhaps you entirely brick the server, your data integrity actually isn't threatened because that data is replicated. MongoDB also provides ACID transactions. ACID transactions are an acronym for certain properties of database transactions that are particularly desirable. So the A in ACID stands for atomicity. This means that database transactions can be treated as indivisible, which is what atomic means. So if there's no partial transactions. A transaction either completes just as it was described, or it fails and is rolled back. There's no such thing as a partial transaction where part of it succeeds and then part of it fails, as this could lead to unpredictability. The C in ACID stands for consistency, which means that the database in a valid state will retain that valid state consistently after the transaction. There won't be any case where a transaction results in a database becoming invalid. I stands for isolation, meaning that every transaction in the database is completely isolated from the others. Even two transactions that occur at roughly the same time won't affect each other. D stands for durability, meaning that any changes that if a transaction successfully completes, the changes that it made to the database are permanent. They can't be lost due to the database, a server crashes or something like that. It's a final change. Another feature that MongoDB has is Atlas, which is essentially just a cloud stored database. If you don't want to create your own database server, MongoDB can provide an online alternative, which is extremely useful. And that's actually where I took this screenshot from, is my own Atlas account. So now I'll show the coding up of a very simple web page in HTML and CSS. So using Emmet here in VS Code, I can just type in an exclamation point, the very quick header of the HTML file. I'll change the title to home. And I'm also going to want to link in my style sheet. So I'll say link, the rel is style sheet. And now here's where I'll put the actual file name, and it's going to be called main.css. Now going over here to the body, let's add in a header. And so in that header, we're going to say Daniel's web page. And we could give the header, for example, a class, but I'm going to use the style of just calling it header, the actual title in the CSS. Now, within this header, let's add in a nav, and we'll have an unordered list. The first list item will be a link to this home page, and we'll say home, and we're going to have another li, and this one will also contain a link, and this one will be to some other page. Let's call it other for now. Now after the header, let's add in a div. This will pretend is going to be for the entire rest of the visible page. We'll give it a class. I'll call that class main. So now that I have this, I can go over to this file main.css, and I can say maybe I want my header to have a certain background color. Aqua is nice. I can then select the class main here, and let's give it a different background color. I'm thinking black. We're also going to want any text we'd want to be visible. So let's put this color as white. Let's go ahead and make sure that our sizes are correct. I'll set the height of this to 10 viewport height units, and I'll set this one to 90. And now let's go ahead and make a very simple other page just to make sure that we got there. So here another, we'll do the same, general HTML emit shortcut. And here we'll just have a div, that says here. And then I'm also going to want the same header. And let's also go ahead and bring in a main. We'll call this main. Let's make sure we link the same style sheet. And now let's pull this up in Chrome to see what it looks like. Here we have our home page, and we can see that our links work. So there you have it. That's a very simple code up of a very simple static web page using HTML and CSS.